All right, so today we're doing the unit circle. So using special right triangles to find the values of trig functions. We're going to start with a review of special right triangles, which you've done before, but have probably forgotten. So if we have a radius of 1 or a hypotenuse of 1 and two angles of 45, the other two sides are always going to be root 2 over 2. For these two triangles, make sure you memorize them because we're going to be using them a ton this trimester, so you want to know them. Here we have a 30, 60, 90 triangle. Again, your hypotenuse is 1. Then the side across from the 30 is going to be a half, and then the side across from the 60 is going to be root 3 over 2. Always, 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 no matter what, you're going to get those two. The way I remember it is 60 is a larger number, and so is 3. So those two go together. 30 is a smaller number, 1 is a small number, those two go together. So the unit circle we've talked about before is a circle with a radius of 1, which means any thing coming up from the center to the side is going to be 1. So then any x-coordinate on the unit circle is going to equal cosine of theta and sine theta. The reasoning being, if we draw a nice right triangle here, this would be our x component, our y component. The radius is always going to be 1, so our hypotenuse is going to be 1. And then if I label this as the opposite side, the adjacent side, and the hypotenuse, we can write out sine, cosine, and tangent. Cosine is going to be your adjacent over your hypotenuse, so x over 1, or x. Sine is going to be the same way, y over 1, or y. And then tangent is still going to be y over x, or you can do sine over cosine. So how can we actually use it? So here we want to figure out our sine, cosine, and tangent of 120. So 120 is our angle coming from the x-axis going over here. So like this. We're going to use reference angles for this. So you're going to come and drop straight down to your x-axis. Always to the x-axis, never draw your triangle to the y-axis. And then we want to figure out what our reference angle, or this angle right here, is. So it's going to end up being 60 because we're 20 away from 180. So this right here is 180. So 180 minus 120 gives us 60. So this isn't your actual angle, it's just a reference angle to help you draw a triangle. So if we have 60 there, we have 30 as our top angle, and we can then label the sides as a half and root 3 over 2, which we can then write here as a half and root 3 over 2. So then sine again is always your y part of your point. So sine of 120 is root 3 over 2. Cosine of 120 is going to be a half. So then to find the tangent, you want to take y over x. So root 3 over 2 divided by a half. Here our 2's are going to cancel, and you're just left with root 3. And that would be your tangent value. This slide we're going to skip and do tomorrow, so you can just ignore that. So a bunch more examples just to give you some ideas. I'll draw some triangles for some of these, and then I'll just give you the answers to the couple, just so we're not doing like a million things on the same page. So sine of 225, you want to figure out what quadrant that is. Again, this is 180, this is 270, 90, and 0. So we're in between 180 and 270. So you can draw this in. This is going to be this one. And you want to figure out, if we draw this triangle, do we have a 30, 60, or 45 degree angle? So if you take 225 and subtract 180, you will end up getting 45. So our reference angle is 45 right here, which makes this root 2 over 2 and root 2 over 2. And then the final thing to check is to make sure your signs are correct. So here we're going in the negative x direction, so you want a negative x. And then we have a negative y direction, so you want a negative y. So then the sine of 225 is going to be the y value, or this right here. So your answer is negative root 2 over 2. So then if we do cosine of 330 in red, this is 360, so 330, we're just a little bit less than that. Draw your triangle. We have a 30 degree angle here. because you've had 30 to 330, you get 360, which makes this a 60 degree. So this has to be root 3 over 2. This side has to be a half, and this one's going to be negative because I'm below the x-axis. And then cosine is your y value. So cosine is your x value. So cosine is going to be root 3 over 2. And then you can keep going with the same idea. So tangent, let's do green of negative 60. So we're coming in this direction, we're at negative 60. This would be 60 and 30, so this was going to be a half here and root 3 over 2 here. So you want y over x, this is going to be negative again. So negative root 3 over 2 divided by negative a half, or positive a half, you're going to get negative root 3 for that one. And then these next two, just to give you the answer, or this next one is going to end up being negative 1. So find your sine value and then take the reciprocal of that. All right, so the unit circle, we have all of our degrees with 30, 45, 60, etc. You can also do these with radians. So we have pi over 6 here, and then you can just keep counting pi over 6s to continue going around. So you have pi over 6, 2 pi over 6, which simplifies to pi over 3. This is going to be, so 1 pi over 6, 2 pi over 6, 3 pi over 6 gives you your nice half, and then you can keep going to get 1 pi over 6, 2 pi over 6, 3 pi over 6. This will be 4 pi over 6, or 2 pi over 3. And keep counting around to get all of your different angles. You can do the same with your pi over 4s. So we have pi over 4, 2 pi over 4, 3 pi over 4, pi. So 4 pi over 4, 5 pi over 4, etc. So if you go down, here's your labeled unit circle if you want it all labeled with all of your degrees. And then we can then use that same idea to find different angles. So pi over 3 is going to be right here. A note, pi over 3 is a 60, pi over 6 is your 30, and pi over 4 is your 45 degree angles. So just memorize those. I'm going to redraw this a little nicer. So here's our angle. Pi over 3 then corresponds to a 60 degree angle. So this is root 3 over 2, and this is a half. So if we're looking for cotangent, we want to figure out x over y. So I do this over here. We want a half over root 3 over 2. These will cancel. You'll get 1 over root 3. If you rationalize the denominator, you end up getting root 3 over 3. So that's your answer. And then you can keep doing the same idea. So 7 pi over 6. Here, this would be pi, or 6 pi over 6. So if we're going to 7 pi over 6, we want to go 1 more. So we're going to be here. And we'll have a 30 degree angle because of a pi over 6. This will be a half, and this will be 3 over 2. Again, making sure they're negative because you're in the third quadrant. And then secant is 1 over cosine. So cosine would be this right here, our negative root 3 over 2. But because we want the reciprocal of that, you get negative 2 over root 3. So then you can try the other two on your own. Here are the answers if you want to check when you're done. Sine of 3 pi over 4 is going to give you root 2 over 2, and a tangent of negative pi over 6 will give you negative root 3 over 3. Okay. So your homework is going to be the 4.3.2 worksheet. If you would like to do the optional homework, it's under 4.3.3.